Okay, now we are going to see locomotives or a trailer, trailers, and then a vehicle up the hill. So here I have still, and I'll show you how it's going to be. We are going to be having this, we are going to deal with the train. Now we have considered that the whole total is going to be, this one is going to be what they are calling, and this one is going to be the train. So because they are going to be climbing up the hill, so that's going to be the case. So as this train is moving, it's going to be bringing these two with it as you see there. So that's the case we are going to consider. We are going to be climbing now along a hill, inclined at some distance. If there is acceleration, this will be deceleration, but we are going to see we are going to be accelerating up the hill there. So that's going to be our work in this lesson. Okay, so now from here, a locomotive of mass, this is the mass of 2,000 kilograms, is connected to a carriage of total mass. So the whole is going to be 130,000 kilograms. So they are connected. So it's connected to this one. So it's connected to that by means of coupling. The train climbs a straight slope inclined at, so they are giving us this angle as theta, that angle, they are giving it as sine inverse of 1/200 to the horizontal with an engine of the locomotive working at 350 kilograms. Because they kilowatts. Because they are giving us kilowatts, we convert them to watts by multiplying through, by 1,000 to convert them to watts, because our power is measured in watts. There. The non-gravitational gravitational resistances opposing the motion are constant, and the total to 2,000 newtons to the locomotive and 80,000 newtons for the carriage. If at a given instant the train is moving at 14 meters per second, that's the velocity, find the driving force produced by the engine. So in they are giving us velocity as 14 meters per second. This is already in meters per second, so we can come for our driving force in our part A. Know that always our power is equal to force times the velocity. So the one is driving force, so our F is going to be P over V, which will be, we get that 300, 350,000 divided by 14. So there are force. This is what we call the attractive force or the driving force. It's going to be, when you get that and divide through, this is going to give us 25,000, and these are going to be newtons. So that's what is going to be pulling that train up the slope. Okay, so then they want us to get the acceleration. So now we can come to our diagram. So this force, we have seen that this force is going to be 25,000 newtons. We are going to be, of course, we shall be having a reaction here. Let us call this R1. And this one also going to be having a reaction R2. Of course, if you resolve this one, its weight is going to be 20,000 G. Of course, we also going to resolve that weight. So this one is going to be, if you have to resolve that weight, it's going to be this 20,000 G sine theta. Then this side, we shall have 10,000 G cos theta. 10,000 G cos theta. Okay, this one, its weight is going to be, we get the mass times gravity. Then this side is going to also have 130,000 G, then sine theta. So remember, this one is going to be having resistance. So let us call this one, this one is going to be having a resistance as it's moving up. It's going to be having resistance which is going to be acting in this direction. We call it R O. Have we used R? Okay, maybe let me use F, the resistance. let me use F. That resistance, which is going to be F1, by giving us that this resistance F1 for the locomotive, they're telling us that it's going to be 2000 newtons, and then for this, it's going to be our F2, which is 8000 newtons. Okay, I think basically we have done everything. So, our theta, first of all, our theta is given by sine inverse of 1 over 200, so sine theta from here, it will be 1 over 200. So that's the case. So basically, because also we are going to be having some tension in this string like that. So we have the driving force. Now the rest is to get the acceleration. Now we are going to be accelerating in that direction there. So after doing that, then we come and then we can concentrate on this. Then we come to this after. Okay, so the 130,000 kilogram mass. So where is our acceleration? Is in that direction there. So what is pulling this in that direction? This direction is going to be, first of all, remember our resultant force is equal to m times the acceleration. So we have this. So we're going to be having this, pulling it up. So we have now t minus, we have this opposing 130 d sine theta. We also have this F2, then plus, minus F2, minus that F2 because it's also acting against that. So minus F2 equaling to MA mass, which is 130, then times the acceleration we are looking for. So from there, if you can put in, let me get my calculator here. Okay, so now here we are going to take our g as 10 meters per second. So it puts t minus now 130,000 into 10. Then our sine theta is 1 over 200. Then minus our F2 which is 8,000 equaling to 1300. So simplifying the all of that, these two zeros will go. So I'll be having now my t, when I take it, okay, t minus, this is going to give me now 0. These two zeros are gone. Then 9 plus. So I have this as 2, 1, 0, 0 equaling to 130. I call this equation 1. Then when I come to the 20,000 kilogram mass. Okay, so still we are in that direction of the acceleration. Our resultant is going to be equaling to MA. What's pulling us in this is that it's going to be the 25,000 force. We have T opposing, then minus this, okay, minus F1 is also opposing, then minus, there is also this force, minus 20,000 G. This one opposing there. This will be equal to the mass, which is 20,000 times the acceleration. And if we simplify this, I'm missing sine theta here. Sine theta is disappeared. And I dropped it. 20,000 sine theta equaling to 20,000 A. So if you have substitute there, we have 25,000 minus t minus f. Our f1 this time is 2000. Our f1 is 2000 minus now 20,000 into 10 into 1 over 200. I forgot to divide this to here. Sorry. And I'm going to break that equaling to 20,000. So remember, we have to divide this to here. So that's the mistake we have done there. Yeah, divide by 2, then plus 8. Yeah, this one is supposed to be 145. Yeah, this one's supposed to be 145,000. Okay, so yeah, these two are supposed to divide this and then we subtract. Okay, so from there, I think you see these two zeros are going to go. So by this one, also 1. So we shall have now this minus. So I have 25,000 minus. Then minus, this one is going to give me, I think that's going to be 30,000. So that's, we shall be adding 22,000 minus t equaling to now 20,000 and this would be equation 2. When we have our equation 2 there, is that we can every add these two. Okay, so from there, 1, we are going to let us say 1 plus 2. 1 plus 2 shall be having t minus 1450. And then here I'm start with this. Then if we add that, what we shall be with, this will go to 0. Then when I add this to this, this will give me 7, 5 equaling to 20. Add this, we shall get 150,000. And from there, and M is that our A is going to be, this is going to be 0.05 meters per second squared. That's our acceleration. So after doing the acceleration, the tension in a coupling, so they want us to get this. You can use any, but this one is the best. So from 1, our T is going to be 130,000 into 0.05, then plus 145. So the 145, 0. So here our tension is going to be 21,000 newtons, and that would be our answer. So that's how we handle that. It was the equations were a bit huge, but here don't forget always these two, we had the notes in that too. So that's how we handle that. As simple as that. So that's it. I wish you well. Don't no worries. This direction of acceleration is the most important thing when you are resolving these things. And also you shouldn't forget that always the resultant force is equal to this is resultant. The resultant force is mass times acceleration. See you in the next lesson.